A leading cause of death and disability in the United States is traumatic brain injury, with between 2 and 4 million concussions a year as a result of sports and recreational activities. While these types of injuries can occur from a variety of incidents, the impacts regularly experienced by football players have been identified as a major source of significant brain injury. Studies have shown that between 50 and 80% of concussions in football players go unreported and untreated. While some of these injuries result from intense singular blows to the head, repeated subconcussive impacts can lead to degenerative brain diseases that develop later in life. One method of studying the effect of these impacts is using instrumented mouthguards that collect data on movement of the skull in order to analyze head kinematics. Our team focused on developing an instrumented mouthguard that monitors a user's skull movement data in order to help predict which collisions are likely to induce brain injury. The few commercially available models have issues with durability, customization, data accuracy, charging, and protection of the enclosed electronics. After discussing multiple options, creating concept sketches, generating models in SolidWorks, and experimenting with different materials, we settled on a design. Our mouthguard's production begins with the customer using an at-home teeth impression kit, which is then sent back to the manufacturer. The oral cavity mold is then filled with plaster, and the resultant casting is placed in a dental vacuum forming machine. Here, a layer of thermoplastic mouthguard material is heated and vacuum sealed around the casting. After trimming the excess material from the casting, the flexible circuit board containing the sensors is attached to this layer using dental-grade adhesive. The production of the circuit board took longer than expected, so we 3D printed a replica of the same dimensions for use in our model. The vacuum sealing process was then repeated on top of the circuit board using an advanced mouthguard material that distributes impact forces over larger areas. After extracting the model from the material, filing down the edges, and filling gaps with a silicone sealant, a 3D printed outer layer is attached to the front. This layer is connected to a strap that can be looped to the face mask of a helmet and also houses the charging wires. This production method results in a fully custom-fit mouthguard that exhibits excellent protection against impacts to the teeth and the hardware. After the circuit boards are fully developed, they can be implemented into the design and data collection can then proceed. Ideally, this data will be used in conjunction with our sponsor's 3D brain modeling technology to demonstrate how impacts to the head affect the movement of the brain. Our final product demonstrates that fit, comfort, and protection can all be achieved in a single design, and hopefully future models will incorporate accurate data collection methods so that brain injuries can both be predicted and protected against.